Hello, student. Today I is going to present SFD and BMD for cantilever beams. And previous lecture we have already uh, seen that we have solved the cantilever beam with UDL. But today I am going to solve more problem in cantilever beams, but different load conditions. So let's see how can I solve this type of cantilever beam and how can I draw the SFD and BMD diagrams. Let's see. Here we can see that it is a cantilever beams because of is one end is fixed. Here we can see that is one end is fixed and other end here the load W kilo 4 kilonewtons load means if 4 kilonewtons it acting over the downward directions at point C. The length of the beam is equal to how much? The length of the beam is 8 plus 6 means 14 meters. Then here A to B, here we can see that A to B is another load, that is UDL load is 2 kilonewton per meter, means how much total magnitude of the load is equal to how much? 2 into 8 means 16 kilonewtons. So this type of loaded beam, how can I draw the SFD and the BMD? Let's see. Here we can see that this is a cantilever beam, so there is no need to find out the reactions. So we have direct find out the SF, then BM, then draw the SFD and the BMD diagram. So let's see how can I find out the SF at different point, then find out the BM at different point. Now for SF at C is equal to how much? SF at C is equal to how much? 4 kilonewton in downward directions. As the previous lectures, as per the sign conventions, when this force is acting the downward direction, so we can take the negative sign, and then 4 kilonewton is downward direction, so 4 kilonewton here. Again, SF at B is equal to how much? And SF at B is equal to how much? Also minus 4 kilonewton, because of there is no load between B and C. So at point B also the 4 kilonewtons. Then SF at A is equal to how much? It is very important because of SF at B is equal to minus 4 kilonewton B. That means this point. But SF at A is equal to how much? Also this force, this UDL force also we take into the considerations here. Take into considerations. So SF at A is equal to minus 4 kilonewton at B, and also summations, algebraic summations, minus 2 kilonewton per meter mean 8, means 2 into 8 means 16. Why 16? Because of 2 kilonewton per meter means 1 meter is equal to 2 kilonewton and 8 meter is equal to what? 16 kilonewton. So then it is add in, it is the algebraic summations, that means minus 20 kilonewton load at point A. I think this way we can easily find out the SF. Then find out the BM. So let's see how can I find out the BM. When we find out the BM, here at BM, or BM at this point, BM at C. BM at C is equal to how much? BM at C is equal to 0. Why 0? Because of here we can see that there is a force in downward direction. There is a force in downward directions minus 4 kilonewton. But if we find out the BM at point C, there's no distance. That means distance equal to 0. The minus 4 into 0, that means 0. Then also find out the BM at point B. Let's see how can I find out the BM at point B. BM at B. That means minus 4 kilonewton this force in downward directions, then distance is equal to how much from point B to C is 6. So you have to multiply this one into 6 minus 24 kilo Newton into meter. Again, we find out the Bm at A is equal to how much? Then here we can see that this force in downward directions and take a distance from C to A. How much distance is equal to 14? So therefore minus 4 into 14. And also take another load here. It is a UDL load. Total UDL load is equal to how much? We have already know that 2 kilonewton per meter and 8, that means 2 into 8 means how much? 16 kilonewton. So therefore total load is equal to 16 millionewtons. But take a distance. What is the distance? We take a distance from the middle of the space. Because of rule of UDL, when you take a distance middle of the space, that means total load UDL is 8, that means 4. 8 by 2 means 4. That means 8 by 2. 8 by 2. So you have to calculate this one. This is the value of how much? So 4 into 14 is equal to how much? 56. So minus 56. Again 16 is to 4 is equal to how much? 16 is to 4 is equal to 64. Then this one is equal to what? How much? 64 plus 56 is equal to 120. So this one is equal to minus 120 kilo Newton into meter. So this way we can easily find out the SF at different point and BM at different point. Now let's see, that is already find out the different BM at different point and SF at different point. Now draw the SFD and BMD. Let's see how can I draw the SFD and BMD. First of all, we take a loaded beam. First of all, take the loaded beam here. So we take a loaded beam. Then after that, draw the SF diagram. Then draw the BM diagram. So first of all, we take the loaded beam here. So first of all, we take, then draw the SFD and SFD, then BMD. Then you can really understand how can I draw the SFD and the BMD. So here we can see that it is the loaded beam here. We take here. So we can easily understand how can I draw. First of all, draw the straight line from the every point. Draw the straight line from the every point, like point A, point B, and the point C. Like I draw different point, draw a straight line from point A, point B, and point C. So take a line from point B. Then take another point, take another line. Take another line. Here. Taking another line here, then take a line here. What is the value of SF at C? SF at C is equal to minus 4. So we take a negative sign here. So another -4 here, then -4 here. There's no force between the B and C. So take a straight line. And again point B. What is the SF at point B? Also 4. Then SF at A is equal to how much? -20. That means up to B is -4. Then up to B is -4. Then here is a UDL. Then take a straight line from the B to C and take another this line. Because of this point is minus of -20. So here is -20. So this diagram is called the SF. This diagram is called the SF diagram. SFD. After that, you draw the BMD. So how can I draw the BMD? Again we take a straight line here. Again we take a straight line here. Then from point B, again I take a line from point B and this one and take a straight line from reference line. Then draw the BM diagram. How can I draw the BM diagram? Here you can see that the BM at C is equal to 0 and BM at B is equal to -24. So here BM at C is equal to 0 and BM at B is equal to -24. So take a straight line from here to here. What is the value of at point B is equal to -24, because of this one is minus of 24. Then here you can see that BM at B is equal to -24. Then BM at A is equal to how much? 1 minus 120 kilonewton. Means, but the force is UDL. So in case of UDL, you have to draw the parabolic curve. So this one you have to draw the parabolic curve. This parabolic curve is not a straight line, but is a parabolic. It is a parabolic. It is a parabolic nature. Parabolic curve. So this one is equal to how much? So this one is equal to minus of 120. So this is the BM diagram for this loaded beam. So this way we can easily draw the SFD and the BMD for the cantilever beam with UDL and so acting the point load. Again, I repeat once, BM at C is equal to 4 Newton because of why the you can see the loaded beam. Then BM at C -4 downward directions, and the BM at B is equal to how much? -4 because of no load between the B and C. That's why -4. BM at A is equal to -4. Minus of 16 kilonewton means 8 into 2 kilonewton into 8 meter distance. That is 16. So 20. Then again BMC is equal to 0. Then BM at B is equal to -4 into 6. -4 downward direction and distance 6 from the point B. That's why -24. Then BM at A is equal to -4 into 14. Distance is equal to C to A 14. Then again 16 UDL load. Then take a distance from the middle of the span 8 by 2, that means 4, and take the calculate 120. After that, draw the SF diagram, different value. You can choose a scaling here. This one -4 because of loaded beam. Then draw the BMD. So this way we can easily draw the SFD and BMD for the cantilever beam. I think you understand. Thank you, student, for watching this video.